back for some maths. We're going to be identifying pairs or more of parallel lines. Parallel lines are lines that never meet. Think about train tracks. The two sides of a train track never touch. They always stay equidistant. They stay the same distance apart. So, I've got two pairs of parallel lines here. I've got some horizontal ones and I've got some vertical ones. But that's not actually the only scenario where we see parallel lines. We can also see them diagonally. But it's just important to demonstrate how to check that they're actually parallel. Now, on purpose, I've made sure that these lines are different lengths, because a misconception is, they have to be the same length. Well, actually, they don't. The important thing for them to be parallel is just making sure the distance in between them is always the same. Now, it might be that you actually have to elongate the initial lines. So if you're unsure, then you just might have to make them longer. But the whole point is they should stay the same distance. So those lines can continue inevitably and they will never touch. But if you're unsure, you can either use a ruler to measure. So I can see, look, I've got 2 centimetres there. If I move further down the line, still 2 centimetres. Or, if you've got squared paper, just counting the boxes. It's 3 apart at the top, 3 apart in the middle, 3 apart at the bottom. If I continued the lines, it would still be 3 apart. So that's my double check there. And the same here. So I've got 2 apart, or I've got 1 centimetre apart. So if I put it on really accurately, actually, looks like it's just over 1 centimetre. But it is the same there. So it looks like it's 1.5 or 1.4 centimetres just under. It might be 1.5. Maybe my ruler's out. Either way, they stay the same distance. So we want to identify these parallel lines within shapes. So I've got an oblong here. Let's just check actually. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Oh, actually it's a square because both sides are the same. So I know here, if I count across or if I measure across, those two lines going vertically are at the top, they're 3.5. At the bottom, they're 3.5. They're 5 boxes apart. So to show that they're parallel, we put these little arrow heads on. I'm going to put them on both sides facing the same way. They could be facing down, but as long as they're facing the same way. But then there's 2 other straight lines within this shape, within our square. So I'm going to check that they're the same distance apart. So 3.5, 3.5, as we'd expect. Now the problem is, if I just put 1 arrowhead on each, I'm now in effect saying that all of them are parallel and they will all never meet. And we know that's wrong because actually some of them are, well, they're meeting in corners, aren't they? They're meeting 4 places. So it doesn't matter which pair we pick, but we're just going to double up some of those arrowheads. So I'll go back to the original ones and I'll double those up. And now because they've got 2, we can tell the difference between the pair on the side and the pair at the top and the bottom. So actually this shape, our square, has 2 pairs of parallel sides, and all rectangles do, a square being a special type of rectangle. So 2 horizontal and 2 vertical parallel sides, parallel lines. So what I'd like you to do is identify as many pairs of parallel lines within shapes as possible. I've got some for you to practice. So you're looking for lines that never meet, that stay the same distance apart. So pause the video and see how many you can find. Okay, let's double check for some answers. So in shape A, hopefully we notice it was actually the top and the bottom lines that were parallel, and we could double check, but we can count, look, there's 4 boxes, there's 4 boxes, and if we did extend that line, so imagine it carried on, it's still going to be 4 boxes apart. For B, we had some vertical ones, but actually we also had some horizontal ones as well. So 2 pairs of parallel lines. And then for shape C, we have got a straight line there, but actually there wasn't anything else that lined up to it. So our lines that were parallel were vertical, but actually there were 3 of them. Now, if I was to continue all of those lines, they're not all the same distance apart from each other, but the ones that matter are. So they're always going to stay the same distance apart, as are they. The important thing to think about is if these lines carry on and on and on, will any of them ever meet? Will any of them ever touch? And actually, if I'm going to carry those on forever and ever and ever, I can even think about the ones on the outside. they're all staying equidistant, they're all staying the same distance away from each other. So, have a go at drawing your normal 2D shapes and see how many parallel lines you can find. Then, like I've done, make up some really random shapes and see if you can make or find any parallel lines within them.